Hi there. Welcome to another live stream. I'm starting a bit earlier today, so I can actually just complete some setup things that I really want to fix. For example, TensorFlow. When I've been running notebooks in the last few live streams, you'll probably have noticed there is an error always coming up, which says clean up code. Okay, and I did a bit of a search in the Kaggle forum, and a couple of people suggested actually to downgrade TensorFlow. Since I don't really want, I'm only supposed to start at 10, but you know, I might as well fix those things now a little bit earlier, because I was able to come into my computer a bit earlier, so yeah, why not? But I don't know if it's going to work because I can see all these errors. I don't know if this worked or not. But I really want to get rid of that error message. So TensorFlow is downgraded. I'm not sure whether it's actually going to work properly. I hope so. I'll find out. And at least I get a chance to actually run the notebook again without wasting time. I also want to try and see if I can get Tensorboard to work, so I can take a look at some of the, you know, the graphs that show the loss and the validation loss, and in a visual way, so we can make some more informed decisions on how long we want to train the model. I also want to try and create a confusion matrix. There was someone in the channel asking how to do that in TensorFlow. So I'll try to also create a confusion matrix for our image classification model. That'll be okay. So I know that TensorFlow has a method that allows you to do that. I just have to. I hope it exists in 2.4 because we're using a old version of TensorFlow now. We'll see. So we have birds, and foxes. So there. If you want a detailed explanation of this notebook, you can check my previous live stream. I go in a lot of detail. So TensorFlow 2.4 should have this method. Okay. So I found a reason why I don't want to downgrade. Because this method is not there. And I don't want to have to rewrite my TensorFlow, my code with an older version of TensorFlow. I will just have to live with those error messages. So what I'm going to do, I'm going to disconnect. Stop switching. Disconnect and connect again. Do that. maybe I can just change this from GPU to TPU. Let's see, I'll put this none, and it's going to restart. I'll try again a GPU. I will need it, and in this way, I'm hoping that I'm going to be on a new instance of TensorFlow of the Kaggle notebook. We'll see if it's on the same version or on so I'm on 2.6.4 again. Restart, make sure everything is okay. So I'm going to run everything. Hopefully it's all going to work in a sequence. All right. So I'm just running the notebook from all the cells again so that it's in the same place that it was yesterday. It's really annoying. I need to figure out how to make these images a bit bigger. Surely this is... This image is too small for me to Okay, I can tell this is definitely not a bird, but this is the last one, which has 40 epochs. It's correct, the size, right? It's doing 40 epochs. It will be longer. While this is running, I can just also see if I can start Tensorboard. Tensorboard. In the loss. Right, so I've managed to run the whole notebook now. What I want to do, I want to activate Tensorboard. So I'm just going to copy this and see if I can enable it. It's telling me that's wrong. Why is it not working here? Years ago. See. This is the same tutorial. Not sure if I want to bother with this. Draw. Can use Matplotlibs to draw the graphs I need anyway. I'm just going to get some examples I did before, rather than reinvent the wheel again. This is not even... to visualize the results. History. Forget about Tensorboard for now. So I have the history here. So I can use that history to try and draw something. Not the binary accuracy, it's going to be the loss. So we have validation loss. Let me see if there's accuracy here. Validation accuracy, okay. Right, so we have val accuracy. Books. Add it here, right? Okay, so we have a chart here, so we can see that the turning accuracy goes up, and the validation accuracy also goes up, which is good. It tells me as well that the validation accuracy is less than the training accuracy, as you kind of expect. When looking at the loss, I think it can still get lower. And we can probably get a higher accuracy as well for the validation. So I should be able to train these a bit more longer, right? So I can do model.fit. Let's do $20 more epochs. What's it doing? Forgot to change it. Quite high. So I'm continuing the training rather than starting from scratch, but I made a mistake. I forgot to change the number of epochs to something smaller. But anyway, you see it's going up to 93. So it's going 95%. I want to 99% if possible. 97, that's for accuracy, not for the training data set. 94. Six, that's good. It's finished. So I was able to get to 0.96 in validation accuracy. It means if I run this again, that's the highest he was able to get to. Now I want to debug something else, which is why these images are showing up so tiny. Nine, 10 rows and 3 columns is what this is saying. Total. Just want to check that all the parameters, they are correct or not. Width. See. Empty. Unless I'm already downsizing the image for whatever reason. See, the more I show, the more smaller it gets. Just have to change this to maybe 2 rows for now. 3 columns, so it's 6. Much easier to see. So these are the prediction here is so tiny. Bird. So this one, it's correct. It says it's a fox. Trust me, it says fox. This one says it's a cat, and it's correct. Cat again, fox, Don't know about this one. Ah, Fox is here. Look. Right, so it's okay, I guess, for now. So this gives me the evaluates everything against the same the garden dataset, which was used for validation, right? So it's probably better for me to create a test dataset just for independent dataset that the model and that hasn't been used for the training. But this is a good result. I just have some so we are using image augmentation, right? We could test as well what happens if we remove it and whether we get better or worse results. I would say I've trained for 80 epochs, but I can do 60. I also wanted to see. Okay, let's do a confusion matrix before anything else. So let's see, Tensorflow confusion matrix. Not sure if this is available in a small. I'm going to make sure it's available on the version 2.6, otherwise, because I don't have 2.6 installed. Let me just double check. Two 2.6. And let's search for confusion matrix. It's there. Okay. So let's look at this example. So the way it works. So there's labels that you pass in, predictions, the number of classes, the weights, the data type, the matrix columns represent the prediction labels and the rows represent the real labels. Okay, the real labels is a control. The confusion matrix is always a 2D array of shape nn, where n is the number of valid labels for a given classification task. Both prediction and labels must be 1D, one-dimension arrays of the same shape in order for this function to work. So we need to have the same number of labels for prediction and the same number of labels for ground truth. If number of classes is set to none, then this will be based on the maximum value. So the labels are actually numbers, not actual strings at this stage. So we would have to convert this into numbers. But we already have done that in a way, because in our image classification model, we have a list of results, and then for each row of 3 numbers, we basically check which one is the highest, and then yeah, so this should be okay. All right, actually. So labels and predictions. Be raw. it would be nice to see actual labels rather than just the numbers, right? So we pass in labels and predictions. So labels and predictions. So let's see how that fits in our notebook. So labels are, where are they? So we do this here anyway, right? So these are the predictions. Predictions. So the predictions, let's make sure. So to predict ID, I think that's what we want. Okay, so this is what we want for predictions. And then for run truth, now we need to find out what's the actual. Predictions and labels. Okay. I think labels is the actual correct classification. It should be similar to this one. But there are two different numbers, right? We have here an example of a confusion matrix. I'm just going to call this without anything else, just to see what kind of, whether it returns anything. Okay. So this is our confusion matrix for these ones. So now I'm going to copy. So prediction IDs is the just print prediction IDs. Predicted IDs. Okay. So we have the first one. Okay. These are the predictions. Then we need the labels. The labels are here, and they should be the same size. This is for a batch of 32, if I'm not. Right, so we have two tensors. Well, one looks more like just an array, but they should have the same length each, so they should have 32 elements here, and this one also should have 32 elements. So passing in the first one. So predicted IDs should have a better name, but it's predictions basically. And then the second one is label batch. Okay. And then we have number of classes, and I'm going to set it to 3. Let's just check the API again. And we have labels, predictions. Okay, labels comes first actually. So labels, and then predictions. Right, this looks a little bit like hard to read, but this is the confusion matrix for this batch of 32. If I do for the whole data set, just check. So we have, this is what you get into Tensorflow 2.6, the confusion matrix. And if I just wanted to see if there's any way to visualize this in a way that it's easy to understand. But we can always add the labels, the actual labels, as a way to read this. So I could probably put this into a Panda data frame. Yeah. Let's see. Let's just see. Okay, I can read this into Pandas. Okay, let's go into the Pandas library. Read from list. There's a way to read the create basically a table from a list of rows. From see. Instead, okay, so the data is going to be our fusion matrix. So I'm going to put this into a variable. Okay. And then I'm going to try and read this into a Pandas data frame. Okay. And then columns. We'll put that into, for now, let me just leave that empty. Don't want to do that yet. So I have to import pandas. Okay, we have the table. Okay, this is better, right? So we have columns and rows. Okay, I can definitely give names to columns, and we can look at the definition. Okay, so we have 0, 1, 2. These are all labels, right? One is predictions and one is ground truth. Just find a definition for confusion matrix. So it's easier to visualize it. Okay. So the actual values goes on the top and the predicted values goes below, right? And then you have two positives. So when this one matches this one, so this one are the true. These are the actual values, right? And we can put that into columns. So 0 is, if I remember correctly, right? Let's do class labels. Class labels somewhere. Basically, I'm looking for the variable where I store the different classes that we are identifying. Forgot the name. Class names. Yeah. Class names. So this should give us the names. So it's going to be in order, right? So bird, cat, and fox. And I wanted to see if I could do something like plus actual. If I could just do that in Python, that would be nice, right? Or I can do something numpy dot map to apply something numpy map. So I want to do a map on the numpy function, so just have to remember, well, find out how to do it. But the idea is I want to just apply a function and basically modify something like this, yeah? So my function should, I'm just being lazy in a way, but maybe I'm okay, so my function should takes a string and I'm just going to concatenate something to it. So actual. Okay. Values. Label. Apply this. Oh, I could do that as well. Not very, doesn't make much sense, this name, but I will change that in a second. Just want to make sure it works first. So it would be class names. Oh. Yeah, so I'm just going to print. Am I doing something wrong here? Just want to find out first. Doesn't like the class names. Oh, this is not what I wanted to do. That's not a map. Data, Numpy Array. Oh, because the data type is a number and print class names. Make sure I have everything correct. Okay, hello. Hi, Ben. I just saw your message. So I'm trying to make a confusion matrix a bit prettier, because right now it's a bit, yeah, it's very numerical. Let's put it that way. What I was trying to do. So Bark, this is an array, right? What's wrong with it? Maybe it's actually not a numpy as I thought it was. It is a numpy array, okay. So why does it not like when I apply a function that appends a string? You function do not contain. Just find out what this error means. It's giving me an error for a panda when I'm not even there yet. It's not panda function. What's wrong with it? first adding two strings together. Okay, so it's a bit more complicated than I thought. What happened there? It disappeared. Here. So you can see, right? Just do something like. So I ended up being able to do what I wanted to do, but with NumPys it's a bit more complicated. So bird actual value. I just wanted to make sure that this is clear. And then I can do the rows. Have now a label here. Two rows equal to, they should. Labels for rows. Equals rain, no rain. Okay, there's index. Okay, it's index. So I can use index here. So index instead of rows. So I could, so PV, I could do AV instead of just making such a huge, you know. Yeah, it'd be easier to read. But I'm still not 100% happy about this anyway. But you see, it's telling me these are true positives, because the actual value, so these two match, right? Oh, this is wrong. Sorry, one second. Preview. So when, for this bird, it predicted 3 times it was a bird and 3 times it was a bird. For this one, for cat, it predicted 16 times it was a cat and it was actually a cat. So you can see actually this confusion matrix gives us very good results actually. So, but this is only for a batch of 32. We would have to do the whole lot to be able to get something more wider. Let me see. But yeah, this is a confusion matrix. You can basically iterate through all the batches up to the point where, so because our data set has batches of 32, and you can iterate through it and concatenate all the results, or you can just call just get all the data set at once and make all the predictions at once. There's many ways, but anyway, this is how we get the confusion matrix. Here, right? What's next? Okay, so we have, I mean, I can see from the loss that we've managed to get really good, decent results, right? And what I can do is do more experiments, and you know, right now I'm only using my garden data set, which means that my model is probably going to be very good at identifying images from my own garden, right? But when I give it, and I can try that now, if I give a data set from the internet, I wonder how accurate it's going to be. So we can actually do that, right? So I'm going to just find out. How, since I used only my garden dataset for the transfer learning, right? So I use the training dataset from my garden dataset, which means it's only my pictures. I only have a couple of foxes coming to my garden, right? So there's not a lot of variety there. And the same thing can be said for birds, right? And for cats. If I now try to test my model with the images from the internet, I kind of expect, right? I expect maybe worse results, but they won't be terrible because we are using a pre-trained model, and this pre-trained model was already trained on this type of images before, right? So I don't know what's the result going to be. I'm curious. So if I now try to evaluate this model, the model which was trained only on my garden dataset, I should get results should we expect. I don't know the answer to this actually, so I'm curious. Let's find out. So I'm going to pass in here my internet. Okay, so is it dataset internet? I forgot. Dataset. Oops. Yeah, it should be something like that. So we got, oh, interesting. So accuracy is quite low. It's actually worse than I thought. So it seems like by virtue of having used only images from my garden, my model is not able to generalize very well now. So if I compare this against for example, the previous experiment, should be better. You can see the accuracy is definitely better. Okay, so you can see the huge difference, even for transfer learning, right? Because in transfer learning, I'm only giving small number of images. I'm also not training the model, all the weights in the model. I'm only training the weights in the model, the last 2 layers or something. So, and it's still, yeah, it's a huge difference. Okay, so what do we do? I can actually experiment now mixing the 2 data sets together. How do we do that? Let's find out. So I have 2 data sets. Can I just do how would I join them together? I'll have to check on Tensorflow website for merging 2 data sets and see. So I have, oh yeah, there's a method for that. We have a concatenate, right? Did I see it correctly? Well, let's see if it still works. Right, my idea is now training a new model with 2 concatenated data sets and see if I can get high enough results both for my dataset and for the internet dataset. Both datasets and do training with both datasets. So I'm going to do internet dataset train, concatenate with garden dataset train. Okay, and let's see if this actually works. Maybe my garden dataset. Okay, not. Okay, just put this here. So yeah, the concatenation seems to work. So I'm going to call it garden and internet dataset train. Okay, so I have a variable here, and now I'm going to just copy and paste this and do the same for the validation. Wow, I don't know why it's red. Did something wrong. Well, oh. Next, I'm going to be initializing a new model. I'm going to train a new model. Copy this. Oops. I'm going to do 40 epochs anyway. So experiment 3, I'm going to have experiment 4. Experiment 4. But I need to initialize it, of course. I'm going to assume everything else is the same, right? So I'm not making any other changes, so it saves me from copying the same code over and over again. Now, experiment 4. I'm actually wondering if it's going to make it worse overall for both datasets, because both datasets are quite different. So I don't know if it's going to... Yeah, I'm curious. So model experiment 4. So this is a very annoying debug from Tensorflow. I can't switch it off, it's a bug. So I've already tried to downgrade Tensorflow, but the problem with that is that you lose functionality that you need. The other option is to try and upgrade it, but I've also read somewhere that it doesn't work with the version of CUDA in this, basically in Kaggle, so we have to live with it. Okay. You can see actually the model is training quite well. Interesting. So I can use both datasets, and that'll be interesting to see, okay, does it do well in just the garden dataset? And then yeah, does it do very well for both after I've trained with both? And that's probably a good thing, right? So that means I could just keep my model a bit more general so I can apply it in other environments. But it still would work well in my own garden. Yeah, at the end of the day. Okay, so I have finished the training, I think. So validation accuracy is 0.96 and validation loss is 0.1214. Okay. Yeah, and then we can do this evaluation now again. Let's do maybe the let's do a training and validation accuracy graphs and just see how it looks like. Maybe I don't need all these prints in it. So I can see now. Well, that's a bit weird. And do I have the right information here? It's interesting to see that there's a spike in a validation, then it goes down. We can see that the validation loss keeps going down. That means we probably can train this a bit more. I don't like the fact that this is a little bit, because yeah, it doesn't, I don't know if it's able to settle down. So maybe I need to do more training and see how it goes. But I don't know if this is the actual. Okay, let's just do an evaluation of the model. So I'm going to copy this code here and evaluate this first against the internet dataset. Oh no, this is using experiment 3. I'm going to use experiment 4. Wow, okay. Something, it's not right. Still quite low. Maybe because it's, actually this spike is very relative because it's quite a high accuracy already. So it goes down, but I just don't understand why this guy is saying this is not good. Maybe because I'm taking the whole data set. So let's try and do let's do this one first. $57. I think I made a mistake. Just gonna confirm. I think I forgot to change something. So I trained on the same data set I had trained before, so that's why. This is probably why I got some really strange results, because I copy and pasted and I forgot to change it. That's why I was getting some really good results. Okay, need to change these values here, so I forgot. Alright, so now maybe the results are not going to be so impressive because I'm training with the correct data now. So we can see it starts. It's able to. It's learning something at least. Okay. Accuracy is going up, but the one that really matters is validation accuracy, because it's the one where the model hasn't seen the images. But you can see actually 0.86 or 86% accuracy is not too bad. .97. Have to wait until it finishes. It's finished. Still running. Bigger data set because I've concatenated both. You can see validation accuracy is quite high actually. We still have a few epochs to go, but the results so far are promising. So what I've done, I've mixed two datasets that I had, and I was able to. I'm hoping now that because I mixed the two datasets, one from the internet and one from my own Raspberry Pi camera, that I'm able to get a model which is more generic, that will work in different environments, not just my garden. But you know, I still think that the dataset from the internet is not great because it's artificial. You know, like the animals always at the center, and that's not going to be something you'll get in real life. Okay. Seems. Don't know if he has finished training or not. I think he has. So he has finished, and it has about. So it was able to reach a validation accuracy of 0.97, which is quite good. Okay, let's look at the training graphs, and you can see the validation accuracy and the training accuracy go up both together, which is, this is almost like a perfect curve, right? It's almost like too good to be true, but that's what's happening right now. So the training loss went down, the validation loss also went down. So it seems like with the bigger data set, it's actually seems like the model has trained a little bit better. Okay, so I'm actually using the same validation data set to avoid the model for now, but at some point I'll create another separate test data set that the model hasn't seen before. But yeah, the accuracy is quite good actually. So for my garden data set, and let me try now for, if I'm going to try as well for the internet dataset. So they now should be able to score quite high, which is awesome. Or did I just copy and paste? My internet. Okay, so internet dataset. All right. So I have now, after concatenating both datasets, one from my garden and one from the internet I was able to get better accuracy for both models. So actually it scored higher. It scored higher even than what it did when I only used, well, take that back, maybe this looks very similar to the score you had before. And let's just do a visual inspection of our predictions. So I'm going to copy and paste some code here. Have a look at our predictions. Image batch. So this is going to just create a small batch of 32. So for 2, I'll be doing. But this is not with the right. I need to use experiment 4. For now, it is only a cat somewhere here. Can't see the cat. Oh yeah, cat is here. A bit hard to see actually. And this one is fox. The fox is here. This is a cat as well. Fox. 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 Here, fox. Yeah, it seems like it's quite good. I can also do a confusion matrix, like I did before. Just put this everything in the same place. Confusion matrix, I should be able to see if there's any like negatives or true positives or anything like that more quickly. Yeah. Oh, so seems like wasn't that good. I mean, it seems like we had more, but this is only a small sample anyway. But here you can see there's some negatives. So it predicted as a bird, and in 3 instances it was a cat. And here for cats it was able to predict every time correctly. For foxes, it misidentified it once. Okay, but most of the times you got it right. So it's still quite good results. I wanted to do this for the whole thing actually. Do So I wanted to do for the whole data set rather than just a couple of, just one batch. So I get a better It's just a little bit more coding to do, but it's going to give me a better confidence. So what I could do, can do a while loop. Does this give me? Just going to find an example. Sorry. So as numpy treated on next. It's finding a good example because I need to do this one. I want to do something like a while next, but while true. So this is an example of what you could do. Can break. Yeah, okay, maybe I should do something like that. Let's see what happens. So while true, basically do this. Now I'm going to avoid doing all the prints. I just want it to fail. So much debug. There is actually some code that TensorFlow recommends using for caching. I don't know if that would remove this error message. Maybe that's what the problem is. Let me just find that. TensorFlow transfer learning. If I go in and find that. So cache. Yeah, this one. Maybe that's what I need to do. because it's like it's trying to go through the whole data set. Let's see, I want to go through the Does it help? Let's find out. No, it still has the same thing. It's not helping. No. Anyway, what I want to do, I'm going to create an empty list of predictions. All predictions, and then I'm going to create I'll call it all labels equal to this. Going to take forever, to be honest. It's okay. Maybe I'll do this next session, but all I wanted to do right now is to try and get the whole data set and then create confusion matrix for everything at once. But it's getting a bit late now, and I've already, I could get this to work next live stream if I wanted to, but the point is I just wanted to have more data. And so the result is that I was able to get a really good model by combining both the dataset that I captured from my own Raspberry Pi camera and the dataset I gathered from the internet. So what I can do now, I can actually, in a live stream, the next live stream, I'm planning to, I'll convert this to TensorFlow Lite. I still need to add more data into this model because I don't have the class. I need two more classes, one for people and one for nothing, basically. I don't want to detect anything when there's nothing there. So those two classes would be important. And it's important to have it so that the model doesn't try to force itself to detect something when there's nothing there. So I'm going to at some point add that extra data, but before I do that, I just want to create a pipeline that will convert the model to TensorFlow Lite, which would allow me to run this on my Raspberry Pi camera. Okay, I'll see you again in the next live stream. Don't forget to click the like button, and I'll see you in the next one. Happy coding!